Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik and today we are going to discuss about the previous year questions of AAI ATC exam, that is Air Traffic Control exam from Airports Authority of India, and the topic that is Special Theory of Relativity. A little bit about myself. I am a Junior Executive ATC at Airports Authority of India. Now let me tell you that Special Theory of Relativity, this topic is very important. This topic is very important as in the last 3 years 4 to 5 questions minimum, or rather I should say 6 to 7 questions, 4 to 5 questions on an average that comes from this topic. So this is very important as almost 15 to 20% questions come. So let's begin our analysis. According to Einstein's prediction in 1905, the measured values of the quantities that depends on the relative motion of the frame of reference and the observer are mass and time, time and length, mass and length, and mass, length and time. See, the quantities that depend on the relative motion of the frame of reference and the observer. See, we have 3 quantities given here: mass, length, and time. Let us analyze. Let's talk about mass. Mass actually depends on the relative motion of the frame of reference, because see, mass, the formula of mass is relativistic mass, m naught by root over of 1 minus v square by c square. Now this, I can say that this is rest mass m naught and m is the relativistic mass. What about time interval for a moving frame, that is time interval at rest frame into, as I can say, root over of 1 minus 1 by gamma 1 by 1 minus v squared by c square. This is actually what I can say here, 1 minus v square by c square. Also we call this as beta square, where beta is equal to v by c. Okay, now this time also, this is called time dilation actually, because for a moving frame this time actually appears to be slow. That means this time interval increases. Okay, what about length? Length delta L dash, that is delta L naught into 1 by gamma. Since gamma is greater than 1, 1 by gamma is less than 1, and the length, actually what happens to the length? Length contraction takes place. So all 3 quantities that actually depends on the frame of reference of the observer, relative motion of the frame of reference of the observer. So my option 4 is correct, that is mass, length and time. Moving on to the next question. The relativistic mass of a proton moving with a speed 2.4 into 10 to the power 8 meter per second, and this is my mass of the rest mass of the proton is given, and the speed of light is given, and we have to find the relativistic mass. See, what is the formula for relativistic mass? We already know m is equal to m naught into gamma. Now let's find gamma for this. Gamma is 1 minus v squared by c square. Here v is given 2.4 into 10 to the power 8, and c is given 3 into 10 to the power 8, and we can cancel out this 10 to the power 8 and 10 to the power 8. This is by 8 and this goes by 10. So 1 minus 8 by 10, 1 minus, that is 6 by 10. Actually it will be squared, so it will come out to be 6 by 10, that is 0.6. So this is coming out to be 0.6. Now this is the rest mass of the proton is given to be 1.67. Actually for gamma it is 1 by root over of this, so this is 1 by 0.6. This is 1 by 0.6. Now we can write here m, that is m naught 1.67 into 10 to the power minus 27 into 1 by 0.6. What is the value of gamma here? Gamma I will be getting 1.67 divided by, let's say 6 2s are 12, 4 7, 6 7s are 42. So my option is coming near to 2.78, and 10 to the power minus 27, this will be almost 2.78 into 10 to the power minus 27. So my option 2 is correct. Now moving on to the next question. A rocket ship is 100 meters in length when measured before leaving the launching pad. When a flight ground observer When in flight, a ground observer measures the length to be 75 meter. The velocity of the rocket ship is. See, this is the problem of length contraction. See, for the person who is inside the rocket, he will measure this length to be 100 meter. But as the rocket is moving with certain velocity, the person who is standing on the ground will measure that this length is actually contracted. This length that this person finds, that is 75 meter. So this is the problem of length contraction, and our velocity we have to find of the rocket ship. Okay, let's find out the velocity. Let's find it out. So what is the formula for length contraction? Length in the moving frame, that is length in the resting frame, into 1 by gamma. So implies that gamma is equal to, I can say, L naught by L. What is L naught? L naught is 100 and L is 75. So I am getting 4 by 3. Now what is gamma? Gamma is 1 by root over of 1 minus v squared by c squared. That is equal to 4 by 3. Implies that 1 minus v squared by c squared, that I am getting as 9 by 16. Now v squared by c squared, that I am getting 1 minus 9 by 16, that is 7 by 16. So v will be root over of 7 by, v will be my root over of 7 by 4 into 16. Root over of 7 by 4 into c. So what is root over of 7 by 4? That my option is coming close to. Now the root over of 7 by 6 by 4, that is coming out ought to be almost, that is coming out to be almost, I can say, 0.66. It is 0.66, and none of the options are correct. So this question was a wrong question, and marks was awarded to all. Next one. An astronaut at rest has a heart rate of 65 beats per minute. When the astronaut spaceship moves at a speed of 0.6 c, her heart rate is measured by an earth will be. See, this is the case of time dilation. That means this, to the person who is standing inside the, let's say, spaceship, time is some, let's say it is del t, and to a person who is standing on the ground, time is del t naught. Then I can say this del t will be slower than del t naught. Why? Because for a person here, this person will observe that this del t is less than, actually greater than del t naught. It is greater than del t naught, because time becomes slow. Time slows down. Time slows down as this velocity increases. And when it is almost at the comparable to the speed of light, say 0.6 into c, that is comparable to the speed of light, then it is noticeable. So I can write the time dilation, that is that equation, that is del t is equal to del t dash into gamma, as this increases. Now del, what I can write here, let me make the reciprocal so that I can find the frequency. So f is equal to f naught into 1 by gamma. F is equal to f naught into 1 by gamma. Now if I can find out the value of gamma, then my job will be easier. Gamma will be 1 by root over of 1 minus 0.6 whole square. That means v by c is 0.6 here. So 1 by 0.8. So gamma will be 0.8. So 1 by gamma will be 0.8. So this is 65 into 0.8. The answer is 52 beats per minute. So my option 2 is correct. Next question. An electron whose rest mass is 9.11 into 10 to the power minus 31 kg moves with a speed of 0.8 c. What is its kinetic energy? Now let's see what is the formula of kinetic energy. Kinetic energy, and for relativistic case, that is m naught c square by root over of 1 minus v squared by c square minus m naught c square. Now if you know, this part is the total energy and this part is the rest mass energy. Let's find out what is the value of this root part. 1 minus, now see it was moving at 0.8 c. This 0.8, 0.6, these are very easy number to calculate. So This is 0.8 squared, so I will get 0.6 because 0.8 squared plus 0.6 squared gives 1. That's a Pythagoras triplet. So our job becomes easy. So m naught c square divided by 0.6 minus m naught c square. If I take m naught c square common, so 1 by 0.6 minus 1, so that is 0.4 by 0.6, that's 2 by 3. So 2 by 3 m naught into c square. 2 by 3 m naught c square. So 2 by 3 into m naught. What is my m naught? M naught is 9.11 into 10 to the power minus 31. 9.11 into 10 to the power minus 31 into c square. C square is 3 into 10 to the power 8, that is 9 into 10 to the power 16. So this 3 and this cancels out. This 6 to 6, 6 9s are this 6, and now this becomes 3, and now 3 9s are 27, 2s are 54. 554.7 into 10 to the power minus 15, so 5.47 into the power minus 14. So my option 4 is correct. The questions are very simple, just you need to understand the theory a little bit. So you have to cover the syllabus, that's it. A nuclear reaction gives off a total of 10 to the power 17 joule energy. How much mass is being spent in the process? This is a very simple question. This is the concept of rest mass energy, that is E is equal to m naught c square. E is equal to m naught c square. Now what is m? So what is m naught? M naught is equal to E by c square. What is E? E is 10 to the power 17, and c I can say 10 to the 9 into 10 to the power 16 c square. 3 into 10 to the power 8 whole square, that is 9 into 10 to the power 16. So that is 1.11 into 10 to the power 0. So 1.11 kg. My option 2 is correct. Next, according to Einstein's prediction, which of the following happens when time interval between two occurring in the inertial frame of reference as frame's velocity with the respect to the observer increases? See, when velocity of the frame increases, that time what happens? Time interval decreases, increases, remains constant, becomes 0 as velocity equals half of the speed of light. See, interval never becomes 0. Interval increases. Why? The option 2 is correct, because this is actually nothing but this time dilation. That means if the speed is increasing, so this is my as speed is increasing. See, 1 minus 1 by v squared by c squared. This is my equation. If v is increasing, then what is happening? This gamma is also increasing. So if gamma is increasing, my time will increase. That means time slows down. Time slows down when speed increases. Time period of a pendulum is 2 seconds in stationary inertial frame of reference. Its period is measured by an observer moving at a speed of 0.6 c with respect to the inertial frame of reference will be. This is another question of time dilation. This is very simple. I can write it here. Time del t is equal to del t naught into gamma. Now what is gamma? Gamma is 1 by root over of 1 minus 0.6 whole square. That is 1 by 0.8. So this will be 2 into 1 by 0.8. That comes out to be 2.5 second. So option A is correct. And this question is that the length of a spaceship is measured exactly to be 1/3 of its length at rest. The speed of the spaceship relative to the ground is observed. This is again a question of length contraction. Now you can see the questions are actually being repeated. So only this type of questions are asked, but I will not say that, I will not guarantee that, because this is a very unpredictable exam and you have to prepare everything. So do not take it lightly just by looking at the standard of the questions. But if these questions come, you have to answer it, because everybody is going to answer. Now for length contraction, I know L is equal to L naught by gamma. So gamma is equal to L naught by L, that is 1/3. So I can write 3. So now root over of 1 minus v squared by c squared is equal to 3 implies that this is 9. So v will be root over of, this will be 9 minus 8 into c. So what is root over of 8? Root over of 8 is, I can say, let me calculate it again. I think there is some mistake. Now this will be L is equal to L naught into 1 by gamma. This is the length contraction formula, and gamma will be L naught by L, that is, what is the length? It is 1/3, so it will be 3 times. So what is gamma? 1 by root over of 1 minus v squared by c squared. This is gamma, and that is equals to 3. Now 1 minus v squared by c squared, that is equal to 1 by 3 squared, that is 1 by 9. So v will be equal to 1 minus 1 by 8 by 9, that is root over of 8 by 3 into c. Now what is root over of 8? Root over 8 is 2 root 2 by 3 into c. 2 root 2, that is 2.8 something, divided by 3, that is 0.94. So my option 4 is correct. Now this question is that a satellite is powered by a small nuclear generator that puts out 15 watt. How much mass is converted into energy in 10 years lifespan of the generator? So it is given the power. Power is 15 watt, that is energy per unit time. Into the time is given 10 years. 10 years has 365 days, and 365 days has 24 hours, and 24 hours have 3600 seconds. And that is equal to mc square. What is m? I don't know. And what is c? M not, I will write rest mass. C is 9 into 10 to the power 16. Now I can cancel out 9. This 9 I can cancel out with this, that is 400. And this is, I can write here, this 15 4s are 60, 60, and this 3 2s are 6, 6. I can write here 24 4s are 96, 96, 3s are 27, that almost 30, 50. So my option is coming out to be, I think if I do the calculation here, I will get 53 microgram, because I can actually do it, this calculation. M naught will come out to be 15 into 365 into 24 into 4 and 1 to 3, that is 10 to the power 3, and divided by 10 to the power 6, this is kg. And again for a gram I can write 10, again one more 10 to the power 3 at the bottom, and this 10 to the power 10 to the power 3 will cancel out, and almost I am getting here. And if I 1 2 3 4 5 6, so 6 digits after 2 digits, so I can write here 10 to the power 6 one more, then I am getting microgram, and almost this is coming close to 50. So I am also showing you how to solve the MCQ without calculator. So this is it. So that's all for this lecture, and if you like my content, then please subscribe to the channel and click on the bell icon. Thank you.